So next, let's talk about fuels. Fuels, well, you know fuels, you've used them, okay? They might be solid like wood or charcoal. They might be liquid like gasoline or gaseous like methane. The primary use of a fuel is to provide heat. So frequently we talk about fuels in terms of their heating value. The heating value is the negative heat of combustion for that material. Now, if liquid water is produced, this is the standard heat of combustion for that material, and that is going to be called the higher heating value. If vapor water is produced, well, then we have to have that energy change to vaporize the water. And so this is a lower heating value. The lower heating value is the higher heating value minus the number of moles of water times 44.01 kilojoules per mole of water. If you have mixtures, the heating value can simply be found using the mole fraction times the heating value in energy per mole, or mass fraction times heating value in energy per mass, and the sum of those for each of the components. And you can do this for either lower heating value or higher heating value. Frequently, you're going to have fuels that are difficult to analyze. Coal is particularly challenging on that one. Really what we can come up with is an elemental analysis. We can burn a sample and then do a test to see how much carbon and how much nitrogen were produced. For a basic typical coal, we have carbon, hydrogen, and oxygen, and maybe some sulfur. And so in that case, if you take the ratios, okay, the elemental number of carbons that are come out in the test, okay, and plug those in here, so plug in the number of carbon atoms, the number of hydrogen atoms, the number of oxygen atoms, and the number of sulfur atoms. This formula will get you an estimate of the higher heating value for that coal in joules per gram. And there's a lot more about this in the textbook. We don't use a lot of coal these days, so I'm not going to spend much time on that, but you should be aware of these things. Now, just kind of so you have a sense of what heating values are for some common fuels, wood has a heating value or higher heating value of about 17 kilojoules per gram. It'll vary a little bit with, whether you're talking about pine or oak. Hard coal is about 35 kilojoules per gram. Gasoline is 44 kilojoules per gram. And natural gas is closer to 54 kilojoules per gram. So you see here that the heating value tells us a lot about how much energy we're going to get by burning a certain amount of a fuel. Another common type of calculation that is done is the adiabatic flame temperature. Now this is the temperature that would be obtained if you carried out the combustion reaction adiabatically, so no heat loss, with no other energy effects. Work is zero, no kinetic energy change, no potential energy change, and the reaction is complete. So it makes CO2, not CO. All of the fuel is 100% consumed. So what you end up doing is a calculation very much like in that previous example we did. You end up with the amount of energy has to go through these various processes. We usually start our feed at 25 degrees C, have the combustion, and then it rises to another temperature. And so based on that, we end up with this calculation here. I have video examples linked in Canvas. You can go on YouTube and find several of these. I even have a couple of them posted. These usually have to be solved using something like Excel. They're not going to be easy to do by hand. But this is an adiabatic flame temperature, and it gives us kind of what is the hottest that I would expect this fire to burn, okay? which is a very useful piece of information when you're talking about a fuel. So this is going to conclude our lessons on mass and energy balances. From here, we're going to take this and we're going to study more about energy balances and thermodynamics. So I wish you the best in your future studies, and thank you for participating.